Ok, on va pouvoir commencer si vous le voulez bien. Donc, ce webinaire WebTech SCS autour de l'intelligence artificielle. SCS, effectivement, depuis avril, a souhaité faire un peu de pédagogie autour de cette technologie prometteuse, innovante et complexe à la fois. Donc, c'est le 13e WebTech SCS, je crois, depuis avril, depuis le confinement. On a décidé ce format et finalement, on va le poursuivre, confinement ou pas, également en 2021. L'intelligence artificielle est partout, dans nos vies quotidiennes, dans tous les débats aussi. Elle a un fort impact sur les vies, la vie quotidienne, mais aussi la vie économique. Et les investissements dans les systèmes d'intelligence artificielle et les cyberattaques sur les infrastructures des entreprises notamment ne cessent de se multiplier ces derniers temps. Et c'est pourquoi la question de la sécurisation de l'intelligence artificielle est clé. C'est un élément clé. Et c'est ce que Shivom va nous aborder aujourd'hui avec ce thème et nous expliquer comment assurer donc la confidentialité, l'intégrité, la disponibilité des systèmes tout au long de leur cycle de vie. Donc, je vais juste vous mentionner le déroulé de ce webinaire. Shivom Agarwal, donc directeur général de Nextra-Partners, va prendre la parole et va présenter donc sa vision des choses pour sécuriser les systèmes IA, une 20-25 minutes. Et ensuite, vous pourrez poser vos questions par écrit dans le module questions en bas du menu GoToWebinar que vous avez. Je les sélectionnerai et les mentionnerai à l'oral. Et Shivom, s'il est en capacité, pourra y répondre en temps réel. Je rappelle que ce webinaire est enregistré et sera disponible en replay pour tous sur le site du pôle SCS dans la session publication vidéo replay et que sa présentation sera disponible pour vous, membres SCS, dans l'intranet du site dans l'accès membres. Voilà, sans plus tarder, je te laisse la parole, Shivom, je te donne la main. Je mets en même temps les prochains événements si vous patientez un petit peu et je te donne la main. Tu m'entends, Shivom?
Oui.
Aïe. Voilà, tu devrais avoir la main.
Ouais.
Donc, Nestra est un membre actif de Etsy, on vient de le voir à l'écran.
Ouais,
Ah oui,
merci.
excuse-moi, j'ai oublié une chose très importante, excusez-moi. La présentation de Shivom, de Nextra-Partners, sera en anglais, mais avec des mots très très simples, donc tout à fait compréhensibles par tous. Et c'est vraiment l'objectif de cette session de sensibilisation, vous faire comprendre des technologies, des technologies et des applications très très complexes avec des mots simples. Et vous allez le voir, ça va être le cas avec Shivom Agarwal. Voilà, je te laisse la parole.
Okay, merci. So today, what we first need to understand when we talk about AI and cybersecurity is what are the major trends happening out there in the market and how they are shaping our cyber future. First thing that we realize is that most enterprises today have started making data governance, data quality, exploitation as part of their strategy. We see this with many of our own clients, whether it's Airbus, CMS, AGM, Naval Group. They are already moving into more and more in this direction. On the other side, we are also saying that AI deployment is happening. It's happening today. It's happening across processes, across departments, across geographies. But it is not secured. Most of the thinking about security in terms of securing AI systems is still taking a back step, because today, when we think about an AI solution, the first thing we try to do is state of the art. We look at the algorithms. What are the latest models available out there? Can we improve a bit of our accuracy in those models or not? But like any other technology, we are following a kind of an S-curve where we see that today we are in the phase of early adoption. Then we will move into mass adoption. Then the technology will stabilize, and then we will start thinking about cybersecurity. But in case of AI, can we really wait until it becomes a mass adopted, omnipresent technology to build security? The other thing that we see today is that AI is not only, we are not only deploying them for internal processes to gain efficiency, to find new use cases, to get new sources of revenue, build new services, but also that it is a technology that is available to the adversaries. So today we already started seeing algorithmic cyber attacks where we are classifying them as advanced persistent threat. It is, the days are gone when you had a hacker sitting somewhere and trying to analyze your network traffic, do a network enumeration, then vulnerability analysis, and then launch an exploit into your network. But today we are talking about automated algorithmic system that do all of this automatically, that also has the capability to design and launch an exploit in real time, depending on what kind of security environment they encounter. On the other side, we cannot only focus on what is happening today. We also have to think what is almost about to come in the near future. And here I'm talking about quantum computing. The world of cybersecurity, AI, cannot be completely separated out from the world of quantum, because they also are related and have a cross impact and interdependence. What we see that today there is a strong need of bridging systems that can bridge between the future of the quantum that is coming and our classic computers. On the other side, we also see that the technology of edge that started some years ago versus cloud computing that started a couple of decades ago, now the two worlds are coming together. This world of the small and the world of the big are coming together in seamless fashion. What it is also doing, on one side, it is creating tremendous amount of opportunities. We already see with some of our work on with video camera companies like Smart TV, that today we need a seamless integration between edge computing and cloud computing infrastructure, so that we can launch a edge computing solutions on individual IoT devices, but at the same time extract data streams from it, and will be able to build more sophisticated solutions at an integrated level at the cloud. But we already know that IoT devices have many security vulnerabilities. We don't even have consensus on many aspects of the design of IoT devices and the protocol stacks that are needed. So when we talk about integrating them with cloud infrastructure, one of the biggest challenges that we face is cybersecurity. Especially when our attack surface increases by thousands and thousands of devices and points of attack, we have to be much more careful about integration between these two technologies. On the other side, we are already seeing that open innovation and external technology partnerships are also happening today. So we see open source codes becoming part of many of our new application developments that we are doing today. This creates its own cybersecurity challenge. And of course, we see, as also Fabian pointed out, we are seeing an increase in number of cyber attacks. And one of the reasons behind this is increase in remote work because of the sanitary conditions that we have today. So we need, this is creating more vulnerabilities, because now the limits of the enterprise network have stretched much beyond the enterprise itself. And the classic frameworks of PKI and AES, public infrastructure and AES encryption mechanisms that most organizations are using today, they are failing to keep these cyber attacks at bay. So first thing that I want to point out is that when we talk about AI systems and AI system design, it's not just algorithms. There is something way more beyond algorithms. What you see that many organizations tend to get stuck at the POC level, at the POC, proof of concept, and they are not able to move to a fully industrialized solution, because there is a huge investments going on from consulting companies and universities and research centers on designing a better algorithm. Let's take an accuracy state of the art with an accuracy of 96%, in terms of prediction, and we want to increase it to 99%. But this 3% improvement may not bring us that much economic value for a business, while there are other aspects of an AI system that brings tremendous value. And this goes into the area of data governance. So first, we look at master data management, where we talk about data lakes, as well as data sources, as well as data engineering, which is about automated data integration, data cleaning, optimization of how the process of extraction and transformation is working. And on the other side, we also have to calibrate our POC models back when we want to industrialize them with new data pipelines, and build custom mechanisms to configure our data lakes to be calibrated with our algorithmic models. There are multiple steps involved when we talk about building an AI system, and many of these steps are now posing vulnerabilities for cyber attacks. This brings us to conversation which started more than 2 years ago, and it took time to formulate and structure it with organizations like Huawei, Orange, British Telecom, cybersecurity agencies of I think 6 European countries, including ANSSI from France, as well as European cybersecurity agency ENISA. They are all members of this specification group. We are also full members there, and have been working on building a technology standard, so that tomorrow every company which wants to deploy an AI system should, or at least have a blueprint in front of them to secure this system. The underlying rationale for this industry specification group for securing AI is that autonomous computing entities may make decisions that act against the relying parties, either by design or by act of a malicious intent. What you see is that the conventional risk analysis and countermeasures do not work completely in case of AI systems. So we need a new way of thinking in this. The 3 scopes that we are really covering within this technology standard that should be coming out in 6 to 8 months, or probably a little bit longer, is securing AI from attacks, where AI is a component in the system that needs defending. We also look at mitigating against AI, where AI is the problem when we are talking about polymorphic viruses or AI-based malwares, as well as using AI to enhance cybersecurity measures against attacks from other things, where we use AI as part of our cybersecurity framework. So some of the things, building blocks of this standard that I wanted to point out is, first, what is this continuum of intelligence? Are we also covering robotic process automation in this, or are we purely talking about deep learning systems, where this is the continuum that relies? So we look at in this continuum in terms of definitions and ontologies. We first start with expert systems. We also look at data mining. We also look at adaptive pattern recognition, then to a certain extent semi-autonomous, then complete autonomy, and then towards a sentient system. We are still far from the last 2-3 steps. Other thing that you look at is the threat tree, that there are different kinds of threats today. We are talking about information loss, information corruption, forgery, masquerading, unauthorized access, which leads to which are encompassed within the manipulation. But we also have denial of service, repudiation, and interception kind of attacks. On the other side, AI can be used for defense. AI can also be used for attacks. There are AI components that need securing from attacks and vulnerabilities. And we can have to think about attacks and defenses to AI systems, where we think about specific vulnerabilities of AI systems in this. So if we look at data supply chain, we talk about first data acquisition. How do we acquire data? We have to do data source qualification. We have to extract the data. Then we have to perform the ETL, extraction, transformation, loading. Within the transformation aspects, we also do some kind of pre-processing, we do some kind of data cleaning, some kind of augmentation of the data, we try to find missing values, predict some kind of mathematical inductions, etc. This is done even before we move into the machine learning side, the algorithmic side of things. And every step of these are vulnerable. When we move into the machine learning side of things, we are talking about other aspects which are quite vulnerable. The architecture definition itself. If we know already that you are using certain components of other technologies in your architecture, then those vulnerabilities also can affect you. We are also talking about parameterization in these ML models, which can also lead to a lot of different type of attacks, more specifically data stealing attacks in this. And some smaller aspects which tend to form a core part of most ML algorithms out there, which is random seeding. We need to find random numbers that will form some part of randomization aspects of my algorithmic model. And this random sampling and random feeding can create another aspects of vulnerabilities. And of course, output testing creates some. Indeed, there are solutions out there. We have been thinking about cryptographic solutions for quite some time. Actually, cryptography makes the basis of most of our security solutions on public internet infrastructure the way we understand it today. Whether we talk about our Facebook password, why it is secured, because data is encrypted. Why our banking passwords are secured, our banking sessions are secured, because it's encrypted. The data in between is encrypted. There are very standard ways for ensuring integrity of data to apply cryptographic hash functions. The major steps that you involve in this kind of cryptographic hash function is first, the providing party provides the data, their hash values, and the digital signature to the verifying party. And then the verifying party can check the correctness of the digital signature, which will not match if the signed values have been modified in the meantime. The logic is very simple. If the signature is valid, the verifying party applies the hash function to the data and compares the results to the signed hash function value. If it all matches, it's good. If the data is tampered, the two values will not match. The classic way of using cryptographic mechanisms. There are some more improvements coming into this, more around hash trees in this, where the approach is more straightforward, where you try to use hash trees for combining many individual hash values and to only digitally sign the root hash of the whole tree. This way, we save some aspects of our bandwidth while the data is being communicated. Of course, hash trees reduces storage space and allow the verification of the integrity of individual data points as well as the whole data set, depending on what level we want to work on. The exact structure of such hash trees should be chosen depending on the requirements in terms of trade-off between storage space. So if you do not have to save the storage space and you are not working with very mass amounts of data, maybe it is not very efficient to use hash trees. We can use more classic hash functions. Depending on how much computation effort you need, logical structure of the data, as well as mechanisms available for you to debug. Common examples of are tiger tree hash or Merkle hash. Now, I want to go a bit more technical and a bit more deep into different types of attacks and what kind of mitigation techniques that can exist today for specifically when we talk about AI systems. I'm first going to focus on poisoning attacks. So in case of poisoning attacks, what we are looking at is that first, they tend to target the data supply chain here. Where they try to poison or change the incoming input of the data, and by virtue of the corrupt input, they want to corrupt the whole system as well as the output. So in this, of course, we need enhanced quality of data, and we need some kind of protection for our supply chain. and we should try to deploy some kind of quantifiable data quality measures in it. But what we see is actually at the development stage, that's where a lot of poisoning attacks are coming. They are not coming at the source or at the extraction stage. They are coming more and more at the development stage, where we are actually talking about the training data sets and the ML models under training. In this, one of the mechanisms, mitigation strategies that we can use is data sanitization. There are already frameworks available like Ronnie, TrainPS, that allow us to do data sanitization before we put the data into the training systems of the machine learning models. Second, we can also think about model agnostic data purifying mechanisms, because most of the mechanisms like data sanitization mechanisms, they are very much dependent on what kind of ML model at the end we're going to use. But there are some new mechanisms available out there, like data trustworthiness and a new algorithm that helps us in checking the integrity and the veracity of the data, called KNHT, and I will be able to give more details and references to Fabian if anyone wants to look in detail later on. What you see in this is the block poisoning without online learning can happen. When we talk about so the specific type of poisoning attack we are looking at is block poisoning, which can happen without learning and which can be mitigated using online learning and gradient shaping. So gradient shaping is one of the interesting technique that I tend to use more and more in learning infrastructure of the ML models, which is delivering very good results more and more. So when we move away from development stage to deployment stage, we can think about a robust combiner, for example, Ensemble, which can help us to move our regular updates and outputs more closer into the model of operation. There are many other types of cyber attacks. One of the cyber attack that we can think about is backdoor attacks. In this, the mitigation mechanisms that work well is trigger detection. If we can figure out where the root cause of this backdoor exists, where does it come from? Was it coming from a rootkit that was already installed in our systems, or is it coming as a part of a large botnet? Depending on where the trigger is, we can focus our energy on mitigating it through there. Of course, the mechanism of data sanitization are still relevant here. This way, we can the raw data is not really available for the attackers to look at. There are other mechanisms for trigger detection here, like spectral signatures or activation clustering that is available today. We can also think about, primarily when we talk about model training, we can talk about model restoration. For example, fine pruning neural cleanse or Tabor. These are two new mathematical models available that can help us to do model restoration. This is their primary use case, but I'm thinking more and more that they can also be used for auditing machine learning models. If we have a way to restore the model that was trained post hoc rather than a priori, then we have a way to actually audit a model. Of course, most deep learning models will be hard to even use fine pruning, but to a certain extent, some convoluted neural networks work better with neural cleanse or Tabor. Deployment stage. In this, what you see is a similar kind of trigger detection that we had in development stage. They can also be applicable here. But we can also have more a preventive mechanism, not only a defensive mechanism. And this can be a pure deactivation. So this is a way where they can cut off this kind of trigger that was starting the backdoor. Or we can try to close the door in the real time. there are some neural network mechanisms for this to input, like strip, Sentinel, Februarus, etc. While we also have some backdoor detection mechanisms, very similar, building on the model restoration idea. But there are others like deep inspect. This is a model. This is a mechanism created purely for neural networks to inspect if there are any backdoors inside the model which is being operated. They try to capture, they try to create different patterns of the operational of the model happening before and after the cyber attack, and try to do some kind of a difference kind of analysis. Evasion attacks. This is another type of attacks, and we see that here we can focus on data pre-processing and transformation, null labeling. This goes also very much into some solutions out there on metadata. If we can work on metadata tagging, and we can use many of blockchain algorithms out there, or some other encryption algorithms, so that metadata of any data set cannot be changed. This is a way of labeling the data throughout the supply chain. If we can secure the metadata through some kind of distributed ledger, then we can see that in such a mechanism, not only the data is auditable and identifiable throughout the supply chain and throughout the model processing, but also helps us in having a kind of a checksum, so that we know if there are any evasion attack, if someone is trying to get into the system as an unauthorized access. Purely on the model side, we have techniques like model hardening, where we can do adversarial training. Basically, you put the model into an adversarial environment where the environment tries to attack the model regularly. Regularization is another mechanism that we see tend to work a bit decently well. Then we can move into more robustness evaluation, where we try to have more model verification certificates. This you can think about model verification certificate as again a kind of a checksum that we built as a designer, had this view of this model versus the model that is running right now. Are the same? What changes have happened, etc. In case of deployment stage, we are talking about AE detection. Here we are specifically talking about evasion attacks. If we can detect them while they are happening, there are we can look at basic patterns of input reference there. We can also think about input restoration. Quantization we use a lot. This is a mechanism that came out of neural network compression, where we try to bring neural networks that exist at the cloud computing or server level. We try to compress them and bring it to the edge systems, and quantization is a common technique that we use in there. But now this technique can also be used to create a security envelope around our in-operation models. While on the output side, again, we can do some kind of ensemble restoration. Model stealing, this is less common kind of an attack, but I think this will become more and more common as we go into the future, and AI systems in itself start being considered as a pure asset. Because today data has been considered and designated as an asset, as back as 2014, World Economic Forum already assigned enterprise data as an asset. But algorithmic systems have not gone into the same direction yet. So model stealing is becoming more, it's upcoming cyber attack. One of the things that we can do is IP management and watermarking. This is common mechanism that we use in large-scale network infrastructure in distributed computing, when we want to check whether the computation in a distributed computing setting happened happened in the same mechanism order that we wanted it to happen. In deployment stage, we are talking about stealing detection. There are specific warning algorithms that are available that we can deploy alongside our operational model. Other thing that we can think about is output obfuscation, that the final outputs are always rounded off. They are not the point output, or you give them a range output rather than a point output. This is a way to think about obfuscation. Or fingerprinting, this is another new technique that we are seeing more and more. It goes back into the extraction warning kind of a mechanism. Besides this, what we see today more and more. So I will go quickly over this. What we see today, there are certain trends that are happening and creating many vulnerabilities. As I already pointed out, edge and cloud integration is happening. So it is creating some cybersecurity implications as well as new opportunities. What we see today, there are new architectures that are coming out. For example, compressed edge twin models that you have the same neural network at the server level. A compressed version of the same neural network exists at the edge device, and only in processing data is transferred. So even if you capture the data in between of this algorithmic system, this data is almost useless because there are so many mathematical functions that have already been performed on it. Of course, new standards are coming out, but also what we see organizations like 1M, 2M, which have moved more into this area and trying to bring consensus across multiple domains. Quantum computing, it's out there. What we see is that companies like Google have already claimed that quantum supremacy exists, although the experiment was a very limited setting. We already know that we have reached the limits of Moore's law. We cannot keep pushing more transistors into a smaller space. So we need more computation power out there. And what we see today, that because of the rise of quantum computers, many governments and research organizations have already started feeling the heat on this. That's why NIST, which is a national science organization in US, started looking at quantum algorithms as a family and started minimizing to see which algorithms of today will still be applicable and quantum safe in tomorrow's world. But it does not mean that we remain only in these kind of algorithms. What we see strongly is there is a new opportunity to build new algorithms that can be applied to, which can work as a bridging system. So some quantum algorithms that can be applied to classic systems. I have some examples like Shor's algorithm, Grover's algorithm. We have quantum approximate optimization algorithm. We have Harrow-Harrison-Lloyd. These are different examples of such algorithms that are existing today. So I would like to close with my final words on the opportunities that are existing today when we talk about AI in cybersecurity. Today, we are able to process millions of data points in real time to build AI-based cybersecurity solutions, not only securing AI solutions. And there are multiple startups who have already built many different kind of models in this. Some really big ones to look at is like Darktrace, which has already raised over $200 million in funding. With this, I would say thank you very much for your time. And if you have any questions, I'll be happy to answer.
Merci beaucoup, Shivom. Oui, on peut rester sur cette slide. N'hésitez pas à poser vos questions par écrit dans le module questions en bas du module GoToWebinar. Donc vos questions sur l'intelligence artificielle et la cybersécurité, son utilité, l'intelligence artificielle comme source de problèmes, mais aussi comme solution. Voilà ce que j'ai retenu aussi de cette présentation. Vous pouvez poser vos questions en français et Shivom tentera de répondre ou en français ou en anglais, c'est au choix.
Merci.
Pas de questions. Vous travaillez peut-être, pendant que les questions sont posées, Shivam, vous, Nextra-Partners, vous travaillez donc sur les, enfin, tu préfères en anglais peut-être?
Oui,
Oui.
c'est plus tard, oui.
Okay. So what is maybe the role of Nextra-Partners in, securing the infrastructure of companies
Yes.
and their AI systems?
Yes. So today, Nextra-Partners work both at the strategy level as well as the technology deployment. So we have our own cybersecurity team. It's still growing. We are 4 people, but we are growing more and more. And we have strong collaboration with Imin, Sedetian, and Gardan, where we can not only do software testing, testing of some of the cybersecurity solutions, but also at the hardware level. So if companies, when we work with companies, we do cybersecurity audit, then build a strategy how to do cybersecurity, and then deploy it.
Okay, thank you. So there is a first question in English. Thank you for writing it in English. So, will homomorphic encryption help to avoid data manipulation before applying AI?
So I probably know from where the question is coming from. I know the company which is doing homomorphic encryptions.
You
yes,
can name it. You can name it.
Homomorphic encryptions, I think, can actually work well, and they can help in managing integrity of the data throughout the data supply chain. The complication with homomorphic encryptions is that they tend to slow down. That the bitrate consumption is a bit higher, especially when we are talking about 10 terabytes of data per second moving in between two data points. So homomorphic encryptions can be a bit slow in that sense.
Okay, thank you. Another question: how long the standardization should take?
Okay, so today the standard is not completely out there. We only have a draft of it out there. The fully validated standard is not out there yet. So we are still not ready on the HC side. The group should, we are envisioning by the end of this year, we will be able to put out a fully specified standard. Then we expect within the standard, we have already specified that if you want to implement the standard within your organization to secure AI systems, it should take on an average from 3 months to 6 months, depending on the type of system and complexity.
Okay, thank you very much. Another question: do the classic protection systems used in IT networks, for example, MAC address filtering, have a future in the field of artificial intelligence?
So this kind of access control, whether it's a MAC-based access control or IP-based access control or any other parameter of identity that we want to use to do access control, those systems, in my personal opinion, my simple, small, humble personal opinion, they will become more and more irrelevant going forward. Because we have other kinds of new identity verification mechanisms that are coming into play. So the classic mechanisms, I do not see of access control will be more relevant tomorrow.
Okay, thank you. Another question. Please help us in asking a question. Otherwise, so we will close the webinar. And as I said, you know, maybe I will put, waiting for another question, the next events, if you send me, if you let me put my screen on.
Yes, Wazi, I will give you this control back. 1 second.
There is another question. Okay, one moment.
Mm-hmm.
Is there a risk of BS, I don't know how to pronounce it, okay, BS, if the data input management is too thorough.
Sorry, I did not understand the question.
I will copy it. I will write it to you maybe in an email or by,
or in the chat. In the chat, I can.
In the chat, okay.
You can send to me.
You should see it now.
Let's go bias if the data input management is too thorough. I think this is an interesting debate out there whether we should use data in a completely raw form when building our AI models, because we have to realize that even the raw data is biased itself. Depends on what kind of biases we are talking about. If we're talking about gender biases, I see this happening in most HR data that I have worked with. They are by default gender biased. So if you take the outcome parameters as well as the input parameters directly from the same data set, most data sets are biased by default. It takes us to a more philosophical question that when we want to build AI systems, we want to build AI systems to be as close to a human behavior. And we know that most of the data that we want to consume in these systems will be coming by human actions. And we know that most humans have biases. And because of these biases, the data by default is biased, whether we're talking about racial bias, gender bias, all kind of biases, and then it goes into the system. But there could be other bias of itself, which is more about the data integrity problems. And in my view, that the more structured data input mechanism that you have, you will find that you have a lower risk of biasing the data.
Okay, thank you. So another question. What do you think about physical digital cryptography primitives like physical unclonable functions in securing AI? Point.
Yes.
Sanitizing and securing the data at the creation step.
Yes, I think it's a brilliant idea. In my view, that this technology is cheap, it works well, and our work is in the standard is less about hardware, is very much about the software side. And once the data has come out, so I think this can be a very complementary mechanism to the securing AI standard that we just covered.
Thank you very much. So I will show, I don't know if you can see, maybe the next events, because I have no more questions. Let me check. So now just a few, donc s'il y a des questions, je ne sais pas si tu les vois, Shivom, tu peux m'en faire part. En tout cas, juste un petit aperçu sur les prochains événements. Je suis en français là. Donc le prochain événement, c'est jeudi, jeudi 12 novembre matin, agenda réduit en matinée 100% digital avec le Smart City and Territory Innovation Day. D'ailleurs, Shivom, tu devrais aussi présenter ton use case innovant autour du Smart Territoire, intégrant de l'intelligence artificielle. 17 startups vont pitcher, ça va être rythmé, mais passionnant, avec les démarches innovation également de la métropole de Marseille, la métropole de Nice, Côte d'Azur, la région qui va présenter des exemples de projets sur des territoires, des projets exemplaires sur des territoires de la région, mais également une table ronde avec le Canal de Provence, avec Enedis, avec le SNEG, l'opérateur de gaz et d'électricité de Monaco notamment. Et puis ensuite, nous aurons le 3 décembre un atelier présentiel qui se convertit également en digital. On est un peu obligé vu la conséquence, vu le contexte sanitaire. Atelier autour du marché du véhicule connecté, véhicule autonome. Quels sont les freins, quelles sont les barrières à l'entrée, quelles sont les opportunités sur ce marché par une personne experte de la filière automotive, j'allais dire, qui connaît cette filière et ce marché sur les doigts de la main, qui viendra donc en digital le 3 décembre à à midi, présenter donc partager en tout cas son savoir-faire et son expertise et répondre à vos questions. La journée annuelle qui devrait se passer le 15 décembre, mais je n'ai pas plus d'éléments aujourd'hui. Et puis le prochain webinaire, WebTech SCS, qui aura lieu le 27 novembre autour de l'industrie du futur. Une opportunité pour les petites et moyennes industries, j'allais dire, entreprises industrielles de la région, avec le parcours Sud Industrie proposé par la région, mais également une opportunité business pour les offreurs de solutions comme Nextra par exemple, des opportunités business pour participer à la transformation digitale de ces entreprises industrielles. Et puis ensuite, un autre webinaire que je suis en train de monter là sur Embedded AI ou Trusted AI, c'est-à-dire l'IA embarquée, l'IA Edge, l'IA Computing, donc l'IA très proche du hardware, du semi-conducteur, donc le lien, la complexité de la relation entre hardware matériel et intelligence artificielle logicielle qui sera donc traité le 11 décembre à 11 h. Voilà, je regarde s'il y a une autre question, mais je ne crois pas. Non, voilà, donc il n'y a pas d'autres questions, donc il ne me reste plus qu'à vous remercier. N'hésitez pas à revenir vers moi ou vers Audrey si vous voulez plus d'informations sur un événement que je viens de mentionner. Shivom, je te remercie vivement pour, encore une fois, le temps disponible et ton partage de savoir-faire et d'expérience avec les auditeurs de ce webinaire. Et puis, je te donne rendez-vous du coup jeudi prochain matin en format digital pour le Smart City and Territory Innovation Day. Voilà.
Okay. Merci beaucoup, Fabienne.
Merci,
et merci
à tous.
Beaucoup pour attendre. Ouais.
Merci à tous et bonne journée, bon week-end un peu en avance. Au revoir.
Au revoir.